Welcome back, everyone. Till now, we have seen the equations of motion, how to derive all the equations of motion, and we've also seen what is the relation between acceleration and velocity, what is the relation between velocity and displacement, and so on. So, we've also looked at which set of formulae to use when the acceleration is constant and when the acceleration is variable. So after all this, let's put our knowledge to test. We're going to solve a few questions, and all these questions have appeared in the JEE mains exam. So it will give you confidence as well. If you're able to solve these questions, that means you have understood the concept properly. All right, let's get started. So here's the first question on the screen. Go through this, take 5 minutes, attempt this question, and then unpause to look at the solution. So let's look at the solution now. The velocity of a particle is given. Its expression or how it varies with time is given to us. And there is an initial condition given that when time was equal to 0 seconds, the displacement was also 0. So this is the initial condition. Initial condition. Initial condition helps us to find out the constant of integration. Okay, and any other constant for that matter. So it is given that at time t equal to 0, x is 0. All right. We'll see how it helps us. We have to find the displacement after time t equal to 1 seconds. All right. Let's get started now. What is given to us is velocity. Goes like v naught plus gt plus ft squared. If we have to find out displacement, how to find it out? What is the relation between displacement and velocity? Well, one could say that x is equal to ut plus half at squared. But remember, this equation was valid only when this was constant. In this question, do we know that acceleration is constant? We don't. So we cannot apply this. What to do now? Now remember the relation v equals dx by dt. This is valid for all cases. Acceleration variable or constant does not matter. This relation is valid for all the cases. So we're going to use this one. Let's do that now. So we know v, this velocity can be expressed as dx by dt. We know that. And this is v naught plus gt plus ft square. So we are going to integrate this now. First, we'll move this dt to that side. Dx is v naught plus gt plus ft square dt. This entire thing is in bracket. And then we integrate the two. Integrate this side also, integrate this side also. Now, we can either integrate definitely or we can integrate indefinitely. So if we know the limits, we can put the limits on both the sides. If we do not know the limits, we'll have to integrate these indefinitely. We have to do indefinite integration. So let's do that. Integration of dx will just give you x. This is equal to integration of v naught dt will give you v naught t. And integration of gt with respect to dt will give you gt square by 2. And the third term will give you ft cube by 3. But we are not done yet. We'll have to add that constant of integration also. Yeah, because this was an indefinite integration, right? So here we have the expression for x or displacement, how it varies with time. Now, if we have to find out the displacement at time t equal to 1 second, all we have to do is substitute t equal to 1 and I'll get my answer. But before that, I have to find out that c, this c here. I have to find out what this constant is. Now, how can I find out that constant? Is any other information given in this question? Anything else which can help us figure out that constant? The initial condition. Let's use that initial condition and find the constant first, and then we'll substitute t equal to 1 and find our answer. All right, so let's do that. We know x is equal to v naught t plus gt square by 2 plus ft cubed by 3 plus that constant c. And the initial condition says that if I put the value of time t as 0, I should get x also as 0. This is what the initial condition tells me. All right, so let's put t equal to 0. This term becomes 0, this becomes 0, this becomes 0, and this is left like that. If I put t equal to 0, the x value should also become 0. So this is what the initial condition is telling me. So from here, I get c value as 0. So I found out the constant. See, all the time you will not get the value of constant as 0. So it's a coincidence. Even if someone skipped the constant, they would still get the correct answer in this case. But please be careful, this won't always be the case. So in some questions, you might get some positive number or some negative number as C. So always a good practice to use the initial condition and check whether the constant is 0 or not. Now comes the final step, which is we know that x is equal to v naught t plus gt square by 2 plus ft cubed by 3. And I have to find out what is the displacement. That means what is the value of x at time t equal to 1 seconds or whatever is the unit. So just substitute t equal to 1 and get the answer. That will be the final answer. X is equal to v naught plus g by 2 plus f by 3. This is option number 3. V naught plus g by 2 plus f by 3. All right, let's move on to the next question now. Again, pause the video for some time, try it out on your own, and then come back to look at the answer and solution. Let's look at the solution now. The position of a particle as a function of time has been given to us. It's this. A, B, and C are constants. When the particle attains zero acceleration, then its velocity will be. So they're asking when acceleration is zero or the magnitude of acceleration is zero, what is the value of velocity? This is what we have to find out. But there's nothing given about the acceleration here. How position is varying with time, that is given to us, but how the acceleration is varying with time, that is not given to us. Can we find that though? From whatever is given to us, from let's say from this equation 1, can we find out how acceleration would vary? It turns out we can. It's just that we have to do it in two steps. First, from x, we'll find out the expression for velocity. Then once we have velocity, we can find out the expression for acceleration. And we know how to do this. Because if you know x, you just differentiate it once. You do dx by dt. Differentiate it once with respect to time, you get velocity. And if you know velocity, you do dv by dt, you get acceleration. Yes or no? So this is what we are going to do. Once we have the expression for acceleration, then we'll use this information, okay? When the particle attains zero acceleration, then we'll equate it to zero and find out the time. Once we find out the time, then we substitute this time in the expression for velocity, which you found out from here. You substitute this value of time here and get the value of velocity. I'll repeat the process once again. See, We'll use equation 1 to find out the expression for velocity. Then we'll find out the expression for acceleration. The expression for acceleration is going to help us find that time at which acceleration is 0, because we'll need that. Once we have this time, we can find out at this time how much was the velocity using the expression for velocity. Okay, so this is the broad process. Now let's jump into the solution. So x, or position, varies like at plus bt square minus ct cube. Velocity, we just differentiate it once with respect to time. So dx by dt will be a plus 2bt minus 3ct square. All right. And dx by dt is actually the velocity. So now I have the expression for velocity. Velocity is equal to this. But we have to find out acceleration, and we know acceleration is dv by dt. So we'll differentiate this part once again with time, with respect to time. Differentiation of a constant term is 0. Differentiation of this term would be 2b, and this term is 6ct. So here we have the expression for acceleration, right? Acceleration is 2b minus 6ct. Fine. Now let's look at the question. The question says when the particle attains zero acceleration. So when does the particle attain zero acceleration? Let's find that out. Put acceleration as this value as 0. This is 2b minus 6ct. So the value of time that you get is 2b by 6c, which is b by 3c. So at this time, the acceleration is 0. Fine. So what about it? So at this time, we have to find out the velocity of the particle. Clear? Let's move on and try to find out the velocity now. Velocity expression we know. This is the expression for velocity. I'll write it again. A plus 2bt minus 3ct square. But how much is the velocity at time t equal to b by 3c? b by 3c. So just substitute that value of time and find out the answer. Let's do that. So this goes like this. We have a plus 2b square by 3c minus 3b square by 9c. So this gives us a plus b square by 3c. A plus b square by 3c. Option B is the correct answer. Right. So I hope you'll be able to do these kinds of questions now. Let's move on to the next question. Again, pause the video, try it yourself, then come back to look at the solution. A particle is, let's look at the solution now. A particle is moving with a speed given as a function of x, not as a function of time. So be careful about that. This is how velocity is changing with respect to displacement. All right. Calculate the speed of the particle at this time t equal to tau, and we have to assume that the particle is at the origin at time t equal to 0. So again, initial condition is given to us. At time t equal to 0, the displacement was also 0. This will help us later. If we had velocity given to us as a function of time, we would be able to figure this out directly by substituting t equal to tau. But what is given to us is velocity as a function of x or displacement, right? So how to go about it now? The answer is, if somehow we could find out how x looks as a function of time, then things would be sorted for us, right? So that's what we are going to do. We're going to try to express x or displacement as a function of time. Let's see if we can do that. V is equal to b root x. And we know v is given as dx by dt. This is equal to b root x. So this gives us dx by root x is equal to b dt. And then you integrate the two and you get something. Yeah, you integrate these two. And this is going to be indefinite integration, and it will give us a constant. And we'll use this initial condition to find out that constant. So let's do this now. So from here, we get x to the power minus half dx. Integral of this is equal to b into t. Constant we'll put at the end. X to the power minus half plus 1 by minus half plus 1, which is 1 by 2, plus some constant is equal to bt. This is what we have. If we write it properly, you will get root x, 2 root x plus c is equal to bt. Or see, we needed x as a function of time, and this equation gives us x as a function of time. You can arrange it nicely and express x as a function of time, square both sides and get it. But we don't really need that, because ultimately what we want is velocity as a function of time, and velocity has root x inside it. So we can directly replace root x, and we'll do that only. Yeah? But before that, we have to find out that constant. So let's find this constant now using the initial condition. So for finding out the constant, we use this initial condition that at time t equal to 0, x is also 0. So 0 here, and this constant also comes out to be 0. Very nice. The constant is 0. We all can see that. Okay. So that means what? 2 root x is equal to b into t, or root x can be written as bt by 2. This is a very important result. So we just now found out root x is equal to bt by 2 from all that calculation. So can we write the expression for velocity now? Can we write velocity as a function of time? We can. See, initially velocity was given as b times root x, but root x is this, so I'll write, instead of root x, I'll write this. So what I'll get is b square t by 2. Now things are very easy. B square t by 2. This will give you the answer if you substitute t is equal to tau. At any given time, it will give you the value of velocity. So they're asking at time t equal to tau, what is the value of velocity? It comes out to be b square tau by 2. B square tau by 2, that's option number B. So this is how we solve this question.